Hi, welcome to lesson 15b, the chain rule. The goal of today's lesson is to differentiate composite functions. So a quick, quick review what we did in the past. We've previously seen the power rule of differentiation, and if we take a look at this, we looked first of all from first principles, and then we did the power rule, the sort of the shortcut of differentiating. If the function is just a constant, the derivative or the gradient function is going to be 0, because a constant is just a horizontal line and the gradient of a horizontal line is 0. So the name of that is differentiating constant. If the function is some power, x to the power n, then the gradient function is going to be n times x to the power n minus 1. And that's differentiating x to the n, or differentiating a power. If there's a constant multiplied by the function, then the derivative is going to be the constant multiplied by the derivative. And if there are two functions that are added or subtracted together, then the derivative, or the gradient function, will be the sum or difference of the derivatives of each one of those functions. Okay, so that would be the addition rule or subtraction rule, I guess. So that's what we've done over the past little while. We've worked on composite functions in the past, and so just as a little refresher, suppose that we have a composite function f of x, which is 3x minus 1, and we have a composite function, or sorry, not a composite function, just a regular function g of x, and that is x squared. Then we can make a composite function by saying g of f of x, which means we're substituting all of f of x in everywhere we see x of g of x. So f of x is being substituted in. So g of x is the main function on the outside like this, and then f of x goes in wherever g of x is, or where the x is in g of x. So 3x minus 1 goes in where the x was of g of x. So it ends up being, because g of x is x squared, then 3x minus 1 all squared is the composite function g of f of x. If we go the other way around, we could say f of g of x, which is where we will substitute all of g of x in for all the x's where we see them in f of x. So we got 3 blank minus 1, which is the main function f of x, and we substitute g of x into the x of f of x, and this then becomes f of g of x. So that can just be written as 3x squared minus 1 then. Okay, we'll take a look at another example here. F of x, let's say this is 5x, and g of x is 2x squared minus 1/3 x. Then if we use a composite composite notation, we can say g composite f of x. That's the same as g of f of x. Then that means, again, we're going to take f of x and we're going to substitute it in for all the x's in g of x. Okay, so here's g of x. Everywhere we see an x, we're going to substitute in f of x. So we have this main structure of g of x, and so f of x is going to be substituted in each of those places where there were an x in g of x. So this is g composite f of x. Now you can simplify it a little bit more, but this is just the main idea of this. And then if we wanted to go the other way around and say f composite g of x, which of course is the same as f of g of x, then we take f, function f of x, and everywhere we see an x in f of x, we're going to substitute in g of x. So the main function is 5x for the f of x, and we'll substitute 2x squared minus 1/3 x in where we see the x of f of x. So this is f composite g of x right here. Okay, so that's just a little review of composite functions. So now what I'd like to do is dive into the chain rule and see what we can come up with. Okay, so I'm just going to give you a few examples of functions, composite functions and their derivatives, and I'm going to see if you can come up with some kind of a rule. So when I display the function and derivative combinations, I'm going to ask you to pause the video and take a little look to see if you can figure out what's going on with these. Okay, so here's the first set. Y is x plus 1 all squared. dy by dx is 2x plus 1. The function y is x plus 1 all cubed. dy by dx is 3x plus 1 all squared. And y x plus 1 all to the power 4, dy by dx is 4x plus 1 all cubed. Okay. Some of the later ones you might need to pause the video and kind of examine to see what you see as happening here. Okay, so this one's pretty straightforward. Okay, so we're going to move on to this next one. Okay, pause the video please and see if you can figure out how we're going from the original functions here and getting the gradient functions over here on this side. Okay, and we're going to move on to the next set. So this is just sort of like exploratory. I'm not going to tell you anything until the end. So pause the video now and take a look to see, of course, how we go from the functions, the original functions y, to the derivative functions here. And a few more sets here. Okay, take a look at these. Pause the video, please. Alright, here's another set. Again, please pause. Okay, now these ones are going to be a little bit trickier now. And so I actually wrote in an intermediate step for you to take a look at, just see if you can figure things out. So we've got the 4x cubed plus 2x squared to the power 2. So the first step of the derivative is 2, 4x cubed plus 2x squared, multiplied by 12x squared plus 4x. And then we just bring this first bracket to the front here. Usually I try to get the smaller factors to the front. For this next one, we've got 4x cubed plus 2x squared again, all cubed. The derivative is 3, 4x cubed plus 2x squared, multiplied by 12x squared plus 4x. And then I'll bring this 12x squared plus 4x to the front. And then for the last one, again, the interior function is the same, to the power 4. The derivative is 4, 12x squared plus 4x. You know what? I have forgotten something here. I apologize profusely. For this function here, there should be a squared here. And henceforth here. I'm sorry about that. And just like here, there should be a cubed here. Okay, that might make things a little bit easier now for you. And then just one last little set. Again, x to the power 4 minus x squared plus x, all cubed, is 3, x to the power 4 minus x squared plus x squared, multiplied by 4x cubed minus 2x plus 1. And then I'll bring this part to the front. And then, usually I would just leave it like this, but in this case I'm expanding this in to give me that. But a lot of times you'll want to factor to make sure that things are in simplest form. And then this last one, 4 multiplies down in front, x to the power 4 minus x squared plus x, all cubed, multiplied by 4x cubed minus 2x plus 1. Okay, so I'm hoping that you saw the pattern and you kind of got a sense of what the rule is for the chain rule, which is differentiating composite functions. And so here is the chain rule, the big chain rule. If you have a function y equals f of x all to the power n, so we don't know what f of x is necessarily, but that whole function is to the power n, so it's a composite function. So dy by dx is going to be n multiplied by that function f of x to the power n minus 1 multiplied by f prime of x. Okay, which basically says you take the derivative of the power, which we have here, and then we multiply that by the derivative of the function on the inside. Okay, so we're going from the outside in. Okay, so that's basically what the chain rule says. Here is an example. If we have y equals x cubed plus 3 all to the power 5, well, the derivative of the gradient function dy by dx, we're going to take the derivative of the outside, so the power, bring that down in front, so we got 5 x cubed plus 3 to the power 4, and then we look inside and we take the derivative of the inside and multiply it together, so we're going to have 3x squared. And then at this stage I would bring that 3x to the front, so I have 3x squared to the front, multiplied by 3x squared, multiplied by x cubed plus 3 to the power 4. Okay, and then from there we might be able to do some other things, and using the chain rule and in these different other rules that we're going to be finding, we're going to be doing some graphing with these in the future, and so being able to differentiate these more complicated functions will allow us then to find characteristics of these functions, like zeros, turning points, etc., etc., and then we'll be able to sketch graphs of them. Okay, so that's coming up. A little bit of foreshadowing for you. And one more example here. So we've got f of x. That's the fourth root of 3x to the power 4 minus 2. So before I take the derivative of this, I'm going to change this fourth root into a power. So I'm going to say that's 3x to the power 4 minus 2 to the power 1/4. Now I'll be able to differentiate that a little bit easier. So f prime of x then, well, we go from the outside in, so it's 1/4, and leave the inside as it is. Don't touch the inside until later. Minus the power 3 to the exponent, negative 3 over 4. Now we go inside and take the derivative of that, so this would give us negative 12x cubed. And then from there is just a little bit of simplification. So I'm going to bring this to the front. So negative 12 times 1/4 will give me negative 3x cubed to the power 3x to the power 4 minus 2 to the power negative 3 over 4. And with that exponent here, that negative exponent, that's going to drop this part down into the denominator, so I'm going to end up with negative 3x cubed in the numerator all over negative 3x to the power 4 minus 2 to the positive 3 over 4. And because the original function was given as in a root form, I'm going to return that to root form. And so I'm going to say that the final value, the final gradient function, or the final derivative, is 3x cubed all over the fourth root of negative 3x to the power 4 minus 2 cubed. Okay, so that's how I would finish this off. Okay, and this is your f prime of x. Okay, so when you do the chain rule, you're taking the derivative from the outside in, do the powers first, and then go inside and take the derivative of the function that's inside. Okay, so tomorrow we're going to take a look at a few more examples and then give you some time to work on these skills. In the meantime, please look at example 5 on page 364, followed by taking a quick look at exercises 1 and 2 on page 364. Then take a look at example 6 on page 366. Of course, all the time you look at examples, please allow the self-tutor to explain things to you. And then finally, take a quick glance at exercises 1 through 6 on page 366. Okay, so thanks for watching, and we'll see you in class.